Hello friends, good evening. Today we'll start with which derivations you have to do for 10th standard physics point of view. Now very first chapter, there is no actual derivation, so they can ask for moment of force, that is not a proper derivation. Second chapter you have derivations like they can ask derive the SI and CGS unit of work, that is 1 joule is equal to 10 raised to 7 erg. There is a small derivation. Then you have derivation like kinetic energy is equal to half mv square. Then you have derivation on relation between kinetic energy and linear momentum, that is k is equal to p square upon 2m. Then there is a work energy theorem where you have to prove work done is equal to half mv square minus half mu square, that is final kinetic energy minus initial kinetic energy. Then you have a derivation on power is equal to F into V. Power is equal to average force into velocity, that part. Then you have a derivation on total energy is conserved, that is it's a big derivation, 4-mark derivation. You have to prove that total energy at point A, B and C, that is freely falling body, where you have to show total energy is conserved, that is mgh at any point. This is about chapter 2. Then third chapter derivation is on relation between ma velocity ratio and efficiency. The efficiency is equal to ma upon vr. Then you have next chapter is fourth chapter. There is as such no derivation. You can have the relation delta is equal to 2I minus a, that is no derivation. Then fifth chapter, nothing, no derivation from fifth chapter. Sixth chapter, no derivation. Seventh is a the seventh is a sound, no derivation. Then eighth, current electricity. Current electricity, they can ask a derivation of R is equal to rho L upon A, that is R is directly proportional to length, inversely proportional to area at constant temperature. Then that R is equal to rho L upon A. Rho is specific resistance. Then you have derivation on effective resistance for series and parallel, that is with the diagram. Draw diagram for series combination and then prove that RS is equal to R1 plus R2 plus R3 and so on. Similarly for parallel combination, 1 upon Rp is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3 and so on. Then next derivation is on nothing. You have electromagnetism, no derivation. You have household circuit, no derivation. Then directly will come to calorimetry. Calorimetry derivation is, they can ask relation, show that there is one question. I can give you the question number. I think it is question number 19 part A. Just a minute. Yes, question number 22, page number 270. The derivation is show that total average temperature T, temperature of mixture is equal to M1C1 T1 plus M2C2 T2 upon M1C1 plus M2C2. That derivation they can ask for 2 marks. Then there is no as such derivation, so that much will be the derivation for physics. Now about the diagrams, which diagram you have to do, that is also important. We'll start from the reverse. We'll start from radioactivity. Now radioactivity, the diagram they can ask is for effect of your electric field and magnetic field. So electric field, where positive terminal, negative terminal, then beta particle move towards opposite polarity, and alpha being positive, they are attracted towards negative terminal. Gamma, they travel straight. They can ask question on based on that part. They can ask question, say they will name it A, B and C. Then they can ask state the properties of A, state the properties of B. Why say gamma is not deflected? Because it is electromagnetic, they do not require any charge. They do not have any charge. Therefore, they are not deflected by electric and magnetic field. Then they can ask a question on magnetic field, where magnetic field is pointing inward, that is cross, which is given in the textbook, where you have to use Fleming's left hand rule. Why beta is deflected towards the right, that is according to Fleming's left hand rule. Now there is a more deflection for beta, less deflection for alpha, because mass of alpha particle is large as compared to beta, and gamma travel straight. Then in calorimetry, the diagrams they can ask is a cooling and heating curve. They can ask what is the melting point, boiling point of substance, AB part is called as what, BC part is called as what, all that part, based on that part. Now there is a diagram of calorimetry. Now initially they are used to ask this diagram in boards, but recently they are not asking. But for safer side, just do it once, just try that diagram and try to avoid such diagrams for drawing, because if you miss any one part of it, you will lose 1 mark. So our target is to get 100 and 100, not 99. Now next diagram is about electromagnetism. It's a very important topic. Now electromagnetism will start directly with the AC generator. The diagram, there we are using slip rings, not split ring commutator, it is slip rings, carbon brushes, then axial, then north south pole, polarity, then that coil, rectangular coil. Now load, you have to mention that part, load. Then DC motor, there is one more diagram of graph, that is sinusoidal wave. That graph they can ask, you have to write there what is E0 plus E0, what is minus E0, and time. Then next part is about DC motor diagram. There is a split ring commutator in that part, write properly, mention properly. Then first part you have that is a current carrying conductor produces magnetic field in the surrounding region. So they can ask question right hand thumb rule based on that part. So or clock rule. There is a solenoid. They can ask you to drawing of solenoid. They can ask you what is the polarity of at A, polarity at B, that way. That is, if the current is flowing clockwise, it is south pole. If the current is flowing anti-clockwise, it is north pole. Now next chapter will be about household circuit. There they can use fuse labeling for fuse. There is a ring system, but don't avoid that ring system diagram. They will cut your marks rather getting more marks. Then they can ask you fuse diagram. Then they can ask for switch diagram. There is a double pole switch. There are 3 diagrams. When both the switch is off, when switch is on through S1, on through S2, all that part. There are 3 diagrams they can ask, frequently asked question. Then you have chapter like current, electricity, experimental verification of Ohm's law, frequently asked diagram. They can ask the diagram for VI graph, IV graph, is a straight line. For ohmic, but now this year they can ask for non-ohmic. Then what is the slope of ohmic? Is a resistance. Non-ohmic, it is which resistance, static, and for non-ohmic it is dynamic resistance. Dynamic is variable. Now next part will be, they can ask question diagram on series and parallel combination. Draw diagram only for series and parallel combination. Then you have sound chapter. They can ask diagram for sonar. Then diagram for free vibration, diagram for forced vibration, not forced, it is damped vibration. Now when you draw that diagram for damped vibration, just make sure that time is equally divided, because amplitude decreases gradually, but it is equally gradually decreases with the time interval equal. Then it is plus a minus a, not a plus a minus. Displacement on y-axis and time on x-axis. Then we'll come to directly, this was which chapter? Sound. Then in sound C part, you have a diagram on say quality diagram they can give. They can diagram for high pitch, low pitch, amplitude is more, which is more loud, that kind of comparison type diagram they can ask. Generally they will give diagram and then ask in which part is more pitch is there, or wavelength is maximum, loud sound is heard, all that part, quality is same, different, all that kind of question. Now we'll go to sixth chapter. Is very important diagram, is a spectrum, diagram of spectrum. There they will not ask, they can give you a white light is incident on a glass prism, the draw necessary diagram. So when they say white light, it is a polychromatic light, so it's split into 7 constituent colors. So when you draw this diagram, just make sure that you are writing left hand side is incident ray, is a white light. You name it, you don't need to write name it. When you go for the emergent part, there you write Vibgyor from V down and R up. So you write draw a line where it is screen, then that Vibgyor, all rays are not parallel, they are bent towards base. So that is one the precautions. Put arrow when you draw any ray diagram, make sure you are doing arrow properly, because if you are not putting arrow, you will get 0 marks for the entire diagram. Now next is a diagram for 5th chapter, that is lens. Obviously, first frequently asked question will be when a light is incident obliquely on convex lens or concave lens. So that diagram is there, very first diagram. Then there are cases, around 6 cases. First is divided to subdivided. Then each diagram you just make sure that when you are drawing diagram, lens is thin, whether it is convex or concave. All these rules are applicable only for thin lenses, not for thick. So if you draw a thick lens, then you will lose marks, you will not get single marks, you will get 0 marks. Now just do when the object is when a convex lens is used, then F2 is on the right hand side, F1 is on left hand side, and correspondingly. Now when you take a reading, you make sure that your distance is 3 cm, 3 cm, 3 cm, or you take whatever 2 cm, but 3 cm is ideal. Now it is not necessary that you have to take 3 cm only, you can take any reading, but distance has to be same throughout. Then frequently asked question will be last case of convex lens, when the object is between optical center and F1, where virtual magnified image is obtained. That is one. Then concave, that last diagram of concave, when the object is placed beyond 2F2, that diagram. Then image form is a virtual, that is most important, dotted line is there. Now about this chapter is this much. Now we will go with the 4th chapter. In 4th chapter, the very first diagram is for lateral displacement. Lateral displacement, when you draw that lateral displacement, just name properly PQ, QR, RS, all that part. Then make sure that emergent ray and the path of incident ray, they are parallel. Then draw lateral displacement, show that part which is not given. It is mentioned in the book, but 90-degree mark is not there, so you just draw that part properly. You draw angle of incidence, angle of refraction, R1, R2, then angle of emergence, then angle of deviation. Then multiple images are formed in case of thick mirror. That diagram also they can ask for, this is a frequently asked question. It is challenging diagram, draw it properly. Then in next part B, there is a prism diagram where they can ask a monochromatic beam of light is incident. Now when that monochromatic beam of light incident, we are drawing diagram only for angle of minimum deviation, where refracted ray is parallel to base of prism. Now there you draw that part, that normal properly. It should be perpendicular to each surface, they can check that part. Then draw angle of deviation. Then that I delta graph, this they can ask for 2 marks, this diagram so 2 marks. Then real depth, apparent depth diagram. So when the object is down, you write O, image is formed in the same line I. Then the real depth, apparent depth. Then shift is not phenomenon, refraction is a phenomenon. Then shift, that formula. Then there is one question where a fish is looking at a tree. Then for him that tree appears taller, so draw that necessary diagram. That diagram is there. Then that's it for the 4th chapter. 3rd chapter, you can have a diagram based on pulley, block and tackle. Then VR equal to 3, where 2 pulleys in upper block, 1 in lower block. Just make sure that strings are not getting mixed with the other strings. Then that pulley with the double grooves with the proper marking at center. Then load, it is acting vertically downward, effort is in downward, all tensions will be what, vertically upward. Then block and tackle for VR3, VR4, VR5, each of 2 marks. Then you have 3 pulleys and 4 string, that kind of question, 2 raised to n wala, that is one fixed and other movable, that kind of question they can ask, diagram. Then in first part they have a lever, there is one more pulley, single fixed, single movable. Now single fixed is one normal pulley, single movable is only movable pulley, but single movable with fixed pulley, that combination they can have. Then you have in first part there is a levers, class 1, class 2, class 3 lever. Then that fulcrum, effort, load, downward, direction is proper required. Then in second chapter, diagram is about that total energy is conserved wala. Then that x wala diagram, the total energy against height wala. Then you have next part like which one? Pendulum, simple pendulum. Now simple pendulum, you have to mention is rigid support, point A, point B, point C. When the point A and C is there, they are extreme points where U equal to mgh, k equal to 0, and main point U equal to 0, k is mgh, all that part. Then you have total energy against height wala graph, that is for 2 marks. Then in part I think part A, now the new question will be W is equal to Fs cos theta, that first diagram. So they can ask component F cos theta, S cos theta, that kind of question they can ask. Then you have in first chapter, uniform circular motion is an accelerated motion, that diagram they can ask. Where V is velocity, you mention that velocity is V over that bar, that is a vector sign. Then next part will be what? They can ask the question on moment of force, principle of moments, total anti-clockwise, rotor clockwise, that kind of question they can ask, that is the diagram. Center of gravity position, they can give a diagram for triangle, rectangle, cylinder, mark the position of center of gravity, that kind of question they can ask. Then first part, that is center, that is moment of force, that diagram generally not asking, but they can ask on that part. Now that's it for that this video. Thank you.